welcome to Zahn Academy. Today we're going to be going over 3Shape's new Splint Studio Program used for designing night guards. To begin, we'll want to start a new case using the blank page icon. You can fill out your customer and patient info as needed. And then choose whichever tooth you want on the arch you plan on putting the night guard on. In this case, I'm going to design on the upper arch. Regardless of which tooth you click, once you add the appliance at the right-hand side, it will automatically add the first option, Splint, to the entire arch. In addition, you may notice that it may default to an odd material for a night guard, but whichever option it chooses under this menu, it will not affect the material choice that we'll make during the design workflow. If you have scans ready to go for this from an intraoral scanner or other system, you can just hit the OK button to exit out. But in my case, I'm going to scan in our models. The scanning process is very similar to your standard crown and bridge or removable scanning workflow, so we're going to speed through this process. After the scanning and alignment steps are complete, it'll take you to this finalization step where you have a couple options for creating the base for the model. Typically, most of the time when you're working on crown and bridge cases or other formats, the scans will save open like this, which usually should work okay, but it tends to make it a little bit easier for splint design if the model's scans are closed. So we'll just use this cut and close option so that it just fills it in with a flat surface. After that's closed, you can continue next, and we're going to skip past the options that let us modify the scan data, and continue and save the scan. After the scanning is complete, when you right-click on the case, it will now have the option to go into the Splint Studio Program. After Splint Studio opens up, we can then begin the splint design. The first step it stops you off at is the Prepare step, where it wants us to place an occlusal table so it better knows how to align the articulator at the next step. This step, we're just going to follow the instructions it gives us. So I'll click on the mesiolingual cusp of number 3. I'll mark the mesioincisal edges right at our midline. One thing to note is if your patient has a diastema, just click on the high point on either side of your midline. And then I'll click the mesiolingual cusp of 14. After that, it readjusts this occlusal table to line up with our model, and you can then tweak that a little bit by changing the orientation from a couple different views. Our goal here is to have this just slightly crossing through the cusp tips of most of the teeth. The next choice to make before continuing forward is what material we're working with. This material choice should remain on whatever material you had chosen last during the Splint Studio workflow, but you can still adjust it here, and it'll change the settings that will pop up at later steps. 3Shape does not currently have every splint manufacturing material on the market. If you don't see one that you're familiar with, you can choose any of these and it will let you modify the settings still. In my case, I'll choose the Roland with the harvest material. And continue next. The next step pulls up the Articulator, which we're going to use to open our bite to make room for the neck guard. The first thing to do before making any changes is to adjust the position of the model in the Articulator. It should be fairly close to where it needs to be based on the occlusal plane we marked in the previous step, but you can still move this around to get things closer to where you want this to be in the Articulator. Once you've got the position of the models exactly where you want, we then want to open our bite. And there are a couple tools that you can use to achieve this, and you'll usually use them in combination. The first tool is this open to splint thickness. So if I'm using material that would have a 2 millimeter thick minimum thickness, I can type in 2 millimeters and hit open, and it will open the incisal pin right here by almost 8 millimeters in this case, which for this model means that no matter where I'm looking around here, the two closest points are going to be 2 millimeters or higher. The problem with just using this tool on its own is because it's only using the incisal pin to open it, it's usually going to be slightly more open at the anteriors compared to where it is at the posteriors. This means that when we adapt against the antagonist at the last step, we may not have enough contact points on the anterior compared to how many contact points we'll have on the posterior. To fix this, I'm going to reset my position, and I'm going to open the bite vertically before opening it using the incisal pin. You start by just single-clicking on whichever arch you want to move, and just use the blue dot to raise it vertically by a set amount, usually somewhere between 0.5 millimeter to 1 millimeter. After opening it vertically, you can then type in whatever value you need. If I need to achieve 2 millimeters, again, you'll click the Open button. And this time it didn't have to open the incisal pin quite as much to achieve 2 millimeters. So in this case, I should have a slightly more even opening across the board. For this patient, I think I'm going to have it closer down to 1.5. After you're happy with the bite position, before you continue next, you must make sure that you hit the lock button so that it stays at this new position that's open. Once that opening is set, you can continue next. It takes us to the insertion direction and blockout stage. The software will always come up with a default insertion direction, which is usually just perpendicular to wherever your model was on your scanning plate. So you'll usually have to adjust this yourself by looking down from an occlusal view, for the most part, and using the Set from View button on the left to set wherever you're looking from as the new insertion path. The software will take a second to load and apply the new directions, and then we'll get to see the new blockout that's happening. So the software will automatically fill in any undercuts based on whatever insertion path you set. In addition, there are some areas that it is intentionally not blocking out for certain undercuts. That's defined by the retention value that we have set here. This value you will have to play around with depending on the material you're working with. If your material isn't very flexible, you'd want to stick to a lower retention value. If your material is flexible enough, it should be able to retain by flexing around the undercuts, so you can use a higher value here. But for this case, I'm going to leave it at just the 0.1 undercuts being exposed, and then continue next. At wax trimming, it'll give us our wax knife tools in order to modify the block out however we wish. Typically at this step, I'm mostly going to use the smooth and add functions. The smooth is what I use the most, just smoothing out all of the interproximal areas. This will make sure that the interior of our night guard won't be allowed to poke or wedge itself in between the interproximals of the teeth. So by smoothing across them, it's filling it in by flattening that little dimple in the scan. So we'll run this across all of the interproximal areas. Additionally, if the patient has particularly deep anatomy, then you may want to use the smooth tool across the deeper parts of the anatomy as well, so that the interior surface doesn't engage into those deep grooves. Additionally, if your patient has particularly sharp cusp tips or a sharp incisal edge, you may also want to add some extra material along those points. By adding our extra wax trimming across this area, it will prevent the night guard from feeling like it's compressing the tips of those teeth. One last area you may want to add material. Some night guards may have to cross over the tissue surface of the scan, in which case we don't want the night guard pressing down on the tissue, so I may add a little extra material across these areas if I have to design my night guard fairly low on the surface. Especially on any prominent bits of the gingival anatomy like the incisal papilla. After adjusting your wax trimming, you can continue next to our outline. At this step, it's going to expect us to draw a line all the way around our scan in order to create the border of our neck guard. You can draw this line wherever you want. Typically, you will want it to be just slightly below any of the blue exposed undercuts, and you don't want your line to terminate on any of the pink areas very much, because those areas are going to be blocked out off the surface of the model. So just draw this where needed, and I'm going to skip past this area to speed up a bit. Once you're happy with where the edges of your neck guard has been placed, you'll then want to double check some of the settings being used on the left. For splint thickness, this is the amount of offset that it's going to create from our teeth to the top of the night guard. So for this, you typically want to have this very similar to the setting that we had opened the bite by. So if I set my opening to 1.5 millimeters, I'll set this roughly around the same, but perhaps a little bit more. For minimum thickness, this will vary based on the material you're working with. Even though my splint is by default going to attempt to be at 1.6 millimeters, it will warn me if I then reduce any areas that go below 1 millimeter. For the offset from teeth to splint, this is going to be your main setting for the spacer in between the night guard and the teeth. So if you're milling out your units and getting a loose fit, you'd want to decrease this offset value. For drill diameter, this is not necessary to use if you're printing your night guard. But if you're using any type of milling machine, you need to make sure it can compensate for those round-tipped milling burrs. So if you're working with a Roland, Gerbeck, or most of the machines on the market, they're mainly going to use a 1mm burr to smooth out areas. So a 1, maybe a little bit extra at 0.2, should be enough for most machines on the market. After adjusting those settings, you can continue next, and it'll take us to the raise surface step. At this stage, it gives you 3 different types of raising that can happen across different parts of our night guard. For the anterior section, we usually like to use the raise ramp. This means that this part that I drag my line across will have a slightly raised surface until it hits the opposing, but that surface will be at a slight angle, which you can define and modify. After waiting for it to preview, it will show us our new result. And this result, it can be a little bit hard to see, but if you look at the wireframe or adjust it, you can see that while it's raised the surface up so it's no longer just sloping around the teeth, it also has a slight angle towards the lingual side, matching whatever angle we defined here. The other 2 options are primarily used for the posterior teeth. The blue one is the raise to antagonist cusp pips. This tool will still raise the surface wherever you paint it, but it will stop only once it reaches the cusp tips of the opposing. This is usually the one I prefer because it's mostly automatic. The third one is raise to antagonist plane. This one gives you a little bit more control over how it's raising to a certain height, because whichever area you paint, it's going to automatically raise it to wherever this plane is, which we can move around to any height we desire. So if I want it raised to this specific height, I'll wait for it to load, and it should automatically adjust this area. So for this case, and most cases, I'm going to use green on the anterior and blue on the 2 posterior segments. And after that's applied, we can continue next. We then reach the Adapt Design, which is the final design step of our neck guard. At this stage, we want to achieve a couple things. The first is we need to make sure that we're not violating the minimum thickness that we had set. We need to run our teeth through their excursive movements and then adapt to those movements to make sure our night guard isn't getting in the way. And then we need to make sure that we smooth out any other rough areas. That's usually the thing I'd take care of first, so I'd switch to the Smooth tool and use a fairly large circle size all across the buccal and lingual surfaces. To run through the movements, you'll click the green play button on the left in the Articulator menu. With this, it will take our opposing and run it through the Articulator, and it will show us exactly where the opposing is intersecting with our design during those movements. After this, I can see the specific highlighted areas. So in this case, I have very few points on the posterior teeth, only a couple here and there, primarily just a couple points of contact on the anteriors. This is where you may have a little bit of trial and error depending on your case. If I want to make sure that I have more contact to the opposing, I might want to add material at this step, or it could mean that at an earlier step, my opening was too much. So you can achieve this a couple different ways. I'm going to use the Add tool at a large circle size and a fairly low strength. And just add all across the surface a little bit. This will also help with some of the thin spots that I have. And hit play to run through those movements again. We see a couple more contact points than we had before. Once you're happy with where you see it intersecting, you can then adapt to those movements using the tooth with the green play button further down. This will take a second to load, but it'll automatically delete any areas that we're intersecting. Depending on the case you're working on, if that deletion exposes additional undercuts, it most likely means that we haven't opened the bite enough. So this step may require a little bit of back and forth going between this adapt design step and modifying your bite at the articulator step. So maybe I'd open this slightly more to 1.7 and locking that as the new position before skipping ahead to that adapt design step again. We'll go back in and use the plus sign tools to fill in any thin spots I may have remaining. And hit the play button to run through those movements. And after the sliders for the movements have stopped, I can then adapt to those movements again. After that, ideally you won't have any more points that are too thin, but again, this may vary depending on the case and what material has the minimum thickness that you're trying to achieve. If you have filled in any thin spots and you've adapted to the opposing and it exposes the thin spots, you generally do not want to fix it by using the plus sign tool, especially on the occlusal or lingual anterior surface. By adjusting that with the plus sign tool, it may mean that your design is still getting in the way of the movements, which most likely means that you'd want to open the bite further, rather than using the plus sign to fix it. But once you're happy with the overall shape of your night guard, you can then proceed next, and it will save and close the case. After the case is finished, it should output the STL to the same place you're used to for your manufacturing directory. You can right-click, go to Advanced, and hit Generate Cam, or F7, to create the STL file. And then right-click, Advanced, and Explore Cam to locate where that STL file is saved. After that, you should have your night guard design finished and ready to send to your mill or printer.